Hey guys, it's Mrs. Conway. So now it is time to learn how to check the solution to a system of equations. So hopefully by now you've gotten a little practice setting up systems of equations from word problems. Now we're going to look at systems of equations that have already been written, and we're going to check to see what the solution, whether a number is a solution. So a solution to a system of two equations is a coordinate point xy that is a solution, and in parentheses here what we're going to do is we're going to put that means it works, because when something's a solution that means that something works. So works for both equations in the system. So I was very clear here that this is for two equations, because if you are talking about a system with three equations, then you're going to need three variables, which we won't do in this class, but that's why I said two there, because it is important that it's two. So the next thing to be aware of is how do we actually do that? So how do we know if a point is a solution to a system of equations? So to determine if a point is a solution to a system, you're going to plug the x value in anywhere there's an x, and plug the y value in anywhere there's a y. You were actually supposed to write plug in here, and then I accidentally, so that should say plug. Plug the x value in everywhere there's an x, and plug the y value in everywhere there's a y. So let's look at, we've got determine which of the choices is a solution for the system of equations. So we've got right here, this is a system of equations. How do I know it's a system of equations? Well, because I have two equations and two variables. And then I have four different options for my possible solutions. So what I have to do is I have to check each of these numbers for x and y in both of the equations. Well, I don't necessarily have to check both equations, because if it doesn't work for one, we know that's not our point. So what I'm going to do is I'm going to take -2, and then instead of x, I'm going to put -2. So I'm going to start with a. So for a, I'm going to take my first equation, I'm going to rewrite it, but instead of x right here, I'm going to put -2, because this is x. And then -6 equals 6 parentheses 3, because 3 is the y. So I'm going to do the math. That's 4 minus 6 equals, and right here you could put a question mark, because we don't know if it's equals. That's what we're trying to find out. 18. No, that's -2 is not 18. So I know that this point doesn't work. And the cool part is now I also know something else. B doesn't work either, because -2 does not, oh no, it could be B. Never mind. We better check. Although we can probably be pretty sure it won't, because if we put -2 in, you get -2 on the left side, and putting -3 would just make that a -18. So I'm going to just say right now that B does not work. Okay, so let's try C. So when I plug C in, let's use a different color. We'll just make a note. Well, hopefully we know it doesn't work. So C, same thing. I'm going to pull my original equation down. So I have -2, and then in parentheses, instead of putting x, I'm going to put 3, because 3 is x. And then I'm still putting -6. And notice for A, I didn't even bother to check the second equation, because the first one didn't work, so there's no point. Equals, hopefully, 6 times -2, which is y. So that's -6 minus 6. Does that equal -12? Yes, it does. So we're on the right track. This point works for the first equation, but we're not done, because now we need to try it for the second equation. So I'm going to take 0. Does that equal -3 times -2 minus 4 times 3 plus 6? See, I just put 3 for x and -2 for y. Does that work? Well, let's see. 0, does that equal -6, or no, that's +6 minus 12 plus 6. 6 minus 12 is negative 6 plus 6 is 0. So it does work. That means it worked for the first point, or the first equation, and the second equation. So now we know that our answer is C, because the numbers for C work for both the top equation and the bottom equation. So C is our answer. All right, so let's try the second one. Oof, that's got fractions in it, doesn't it? So you'll want to pull out that calculator. And we're gonna do the same process. So we're just going to check each of these equations with these numbers and see if it works. So for A, I'm going to start by doing, does 0 equal negative 4? So I'm taking this equation, I'm rewriting it, but I'm putting negative 4 for x and 1 for y. Minus 4 over 5 times 1 plus 16 over 5. And this is where I would just get out my calculator. Over 5 times 1, which is just 1, right? Plus 16 over 5. And I got 6 2/5, which is distinctly not 0. 0 is not equal to 6 2/5. So A is not the correct answer. So I don't even have to check the second equation because it didn't work for the first one. Okay, let's try B. Although I have my doubts about B because it's, again, you've got that same number for the first one, but we'll try it. Because I didn't show as much work for this one, it's going to be harder to tell how much it worked. Okay, so I'm going to take that equation, 0 equals, but instead of negative 4 and 1, I'm going to put 4 and negative 1. Depending on the calculator you're using here, you might just be able to go up and change those numbers. So I'm going to change that to a positive 4, and then I'm going to multiply the negative 4/5 by negative 1, which basically just makes it a positive. Ooh, and that time I did get 0. So it surprised me. So 0 equals 0. Now, we're not done yet. That just means it works for the first equation. Now we have to try it in the second one too. So for B, x is 4 and y is negative 1. So I'm going to put negative 4 because it's negative x. So I'm taking this equation, I'm writing it right down here, but I'm putting negative 4, or 4 for x and negative 1 for y. Does that equal negative 16 over 3 minus 4 over 3 times negative 1? Okay, so now in this one, the trick is I'm not going to plug the whole thing in. I'm only going to plug everything on the right side of the equation in. That's just going to be negative 4 right here. And then I have to put this in my calculator. Negative 16 over 3 minus, and I can't read my own handwriting, that's 4/3 times negative 1. Ooh, I messed up. Okay, and so when I did that, I got negative 4. So that means that that point also works for the second equation, which means we are done with that problem. So the answer for question 4, which is the second one we just did, is B, because when we put B, that number, these two numbers in for x and y, we got it worked for both equations. All right, so the answer for this one is B. Okay, so now if you're thinking you're understanding this, I want you to go ahead and try 5 and 6 on your own. Just hit pause, try them out, and then hit play and see if you got them right. So if you've hit play, you should be ready for me to go over this one. So, again, I just need to start. I'm going to start with A because I like to be systematic. So I'm going to plug 3 for x and 1 for y and do the math and see if it comes out right. So checking A, 9 plus 3. Okay, but notice y is first, so I have to put 1 first. Minus 2 times 3. Is that 0? I'm thinking not because, yeah, maybe. So I've got 9 plus 3 minus 6. No, because that's going to be 12 minus 6, which is just 6. So that's not 0. So A does not work. Okay, let's try B. So I'm going to put negative 2 for x and 1 for y. So I've got 9 plus 3 times 1 minus 2 times negative 2. Does that equal 0? And you could check the second equation first, but actually these ones that equal 0 are a little easier to check. So that's going to be 12 again. Minus 4 is not going to be 0. It's going to be 8. So B doesn't work. So now we got to try C. I'm going to get a new color. So C, I'm going to do 3 is x and negative 1 is y. So I'm going to have 9 plus 3 times negative 1 minus 2 times 3. Is that 0? So that is 9 minus 3 minus 6, which is 0. So we know that that point works for the top equation. And I am now out of room on my paper. So I'm going to erase my work for A because we know that didn't work. And hopefully you've already got it written down somewhere. And we'll do C number 2 right here. So now I have to check the second equation. So remember, the second equation was negative 3 plus 2x equals negative 3y. So negative 3 plus 2 times 3, is that equal to negative 3 times negative 1? Right, because y is negative 1. So that is negative 3 plus 6, and that is 3 on the right side. So that's 3, and that's 3, so it works. So C is the solution. All right, one more. Hopefully you're starting to get the hang of this now, so you might be able to try that one on your own. And you might not have to show all these steps. Maybe you just make yourself a quick note here. Y is 4, x is 4, and then you put it in your calculator. But I'm going to keep writing it all out. So for 6, again, if you want to hit pause and then do it and then come back and hit play, feel free. For 6, both x and y are 4 for A. So we're going to try A first. So 0 equals 4 minus 3 minus 4. Is that going to be true? Probably not so much, because that's 1 minus 4 is negative 3. So 0 is not equal to that. Okay, so it's not A. Let's try B. B, x is negative 4 and y is negative 4. So let's try the same one again. 0 equals negative 4 minus 3 minus negative 4. Again, we're going to run into problems here because those negative 4s basically cancel out. So you're just left with 0 equals negative 3, and that's not true, so it's not B. Basically, x and y can't be the same thing for that one to work out. Okay, let's try C. So now we're going to have 0 equals, and negative 4 is x and 4 is y. So y comes first, so it's 4 minus 3 minus negative 4. So now is 0 equal to, that's going to be 1 plus 4, not so much. So it's not C either, which kind of leaves D, but I would like to just kind of confirm. So for D, we would have 0 equals negative 1 minus 3 minus negative 4, which would be negative 4 plus 4, which is 0. So it works for the first point. And then for the second one, which we never even got to try before, we'd have negative 6 equals 2 times negative 1 plus negative 4, which is negative 6 equals negative 2 minus 4, which is negative 6. So it works out. So D is the answer for question 6. So hopefully you're starting to understand this. There's some Delta math practice to go with this. But let's look too at just like a word problem, because we started with word problems, so I want to keep the word problem thing rolling. And this is also just sort of an example if you were struggling with the first Delta math assignment for how to write equations from word problems. So here is just a basic word problem. This is one of everyone's favorite systems of equations type problems. So Wilbur's school is selling tickets to a play. On the first day of ticket sales, the school sold 8 senior citizen tickets and 4 child tickets for a total of $96. So we've got first day, 8 senior and 4 child for a total of $96. They took in $60 on the second day by selling 6 senior citizen tickets and 1 child ticket. Find the price of a senior citizen ticket and the price of a child ticket. And then I want you to prove that 9,6 is the solution for the system, because we haven't really talked about how to solve these kind yet, so I just want right now to prove it. So the first thing we have to do here is we have to identify our variables. So what does X stand for and what does Y stand for? And commonly, you're going to see X being the first number, like the first thing that we're asked to find, and Y being the second thing. So it says find the price of a senior citizen ticket and the price of a child ticket. So that means X is going to be the price of a senior citizen ticket, and Y is going to be the price of a child ticket. And note here for both of these, my description of the variable is a phrase, something you could finish and make into a sentence that's your answer, okay? Now let's write our equations. This is one of the more straightforward ones. Each of these sentences is an equation. You have day 1 equation and day 2 equation. So the first day of ticket sales, the school sold 8 senior citizen tickets and 4 child tickets. So that's just about as straightforward as it sounds. Hopefully that sounds straightforward to you. So you have 8x, because X is senior citizen tickets, plus 4y is $96. And then you have day 2 if it helps. You have 6 senior citizen tickets and 1 child ticket. So you have 6x plus 1y equals $60. So to prove this, we're just going to do what we did before. We're going to plug 9,6 in, 9 for X and 6 for Y, and make sure it works. So if we do 8 times 9 plus, that's 4. I know it looks like a 9, but it's a 4 times 6. Do we get $96? And so if I take my calculator, 8 times 6 is 96. So that's 96 equals 96. So that's proving it for the first equation. The second equation, I'm going to do 6 times 9 plus 1 times 6. Is that 60? Well, 6 times 9 is 54, plus 6 is 60. So it does work. 9,6 works for both. Okay. Now, then it says, then write the answer in a complete sentence. So what you would write down here is the price of a senior citizen ticket is $9 and the price of a child ticket is $6. So hopefully now you have the ability to do some practice on Delta Math, and if you have any questions, make sure to check in at office hours or email me and I'll see what I can do to help you. Good luck!